Press the bell icon on the YouTube app and never miss another update.
Hello, good morning students. Today I am taking the second chapter of second PU, that is inverse trigonometric functions. Before starting inverse trigonometric functions, we have to know about the trigonometric functions and their formulae, that is allied angle properties, compound angles formulae, multiple angles formulae, and transformation formulae. Each and every formulae, so they are used while solving the inverse trigonometric functions problems. So first we should know the formulae of the trigonometric functions. We know that there are 6 trigonometric functions or the ratios, so which are defined with the angle, and the answer is always a real number. So now the sine of an angle theta, so it is written as sine theta, and in terms of that is the sides, it is written as opposite side by hypotenuse side. Co-ratio of sine, that is cos theta, so it is written as cos theta equal to, in terms of sides, it is nothing but adjacent side divided by the hypotenuse side. Tangent of an angle theta, so it is written as tan theta in terms of sides, so we write it as opposite side by adjacent side. The co-ratio of tan theta, that is cotangent of an angle theta, it is written as cot theta, so in terms of sides, it is defined as adjacent side divided by the opposite side. Secant of an angle theta, it is written as secant theta, or we can spell it as sec theta, equal to, that is hypotenuse side divided by the adjacent side. The co-ratio of secant, it is written as cosec theta, so in terms of sides we have hypotenuse side by opposite side. These are the 6 trigonometric ratios, so in terms of sides. There are identities with respect to the 6 trigonometric functions. So the 6 trigonometric functions, the identities are, the first one is the reciprocal relation. So reciprocal relation, so we know that the reciprocal relation, that is sine theta and the cosec theta, so these two are reciprocal to each other, and we can write this as sine theta into cosec theta, it is equal to 1. So therefore sine theta equal to 1 divided by cosec theta. So or we can write this as cosec theta equal to 1 divided by sine theta. The second one is here, that is cos theta and secant theta. These two are reciprocal to each other, and hence we have cos theta into secant theta equal to 1. So therefore cos theta equal to 1 divided by secant theta, or secant theta equal to 1 divided by cos theta. The third one is tan theta and cot theta. They are reciprocal to each other, and hence we can write this as tan theta into cot theta equal to 1. Therefore tan theta, it is equal to 1 divided by cot theta, or cot theta, it is equal to 1 divided by tan theta. These three are the reciprocal relations. So that is between the 6 trigonometric ratios. The second one, that is the next relation, is that it is called as the identity. The first identity is sine square theta plus cos square theta equal to 1. So we can express this identity as sine square theta, it is equal to 1 minus cos square theta. While solving the problems, this can also be expressed as, it is in the form of a square minus b square. To simplify the problem, we can express this as, 1 plus cos theta into 1 minus cos theta, or cos square theta, it is equal to 1 minus sine square theta. This can also be written as 1 plus sine theta into 1 minus sine theta. Next, the second identity is, 1 plus tan square theta, it is equal to secant square theta. So this identity it is also used while integrating the function, that is tan square theta, that is therefore tan square theta, it is equal to secant square theta minus 1. This can also be written as secant theta plus 1 into secant theta minus 1, or 1 equal to secant square theta minus tan square theta. So this is equal to secant theta plus tan theta into secant theta minus tan theta. So the third identity is, that is 1 plus cot square theta, it is equal to cosec square theta, or cot square theta, it is equal to cosecant square theta minus 1. This can also be written as cosecant theta plus 1 into cosecant theta minus 1, or it can also be written as 1 equal to cosecant square theta minus cot square theta. This can also be written as in the form of a plus b into a minus b, that is cosecant theta plus cot theta into cosecant theta minus cot theta. And also we have the other two relations, that is we can express tan theta equal to, in terms of sine and cos ratio, that is tan theta, it is equal to sine theta divided by cos theta, and cot theta, which is the reciprocal of tan, this can be expressed as cos theta divided by sine theta. So these are the basic of the trigonometric functions. So the reciprocal relation, there are 3 reciprocal relations and there are 3 identities, and also we have tan theta equal to sine theta by cos theta and cot theta equal to cos theta divided by sine theta. The next is here, the next unit is, that is about the quadrant rule. That means in which quadrant the ratios are taken as positive and the ratios are taken as negative. According to the quadrant rule, this is called as quadrant rule. The two mutually perpendicular lines, they divide the plane into four parts, where the parts are called quadrants. So this is taken as first quadrant, this is second quadrant, third quadrant, and this is taken as fourth quadrant. The first quadrant is formed by the positive x-axis and positive y-axis. The second quadrant is formed by negative x-axis and positive y-axis. The third quadrant is formed by negative x-axis and negative y-axis. And the fourth quadrant, it is formed by the positive x-axis and the negative y-axis. So we know that if the sign of any point which lies in the first quadrant, it must have the sign that is plus comma plus. Both x coordinate must be positive and y coordinate must be positive. In second quadrant, negative and positive. X sign, x coordinate sign negative and y coordinate sign negative. If both the sign are negative, then that point it will lies in the third quadrant, and in the fourth quadrant x coordinate must have positive sign and y coordinate must have negative sign. So here, according to the quadrant rule, if the point lies in the first quadrant, then we have both x and y as positive, and we know that. So here, this is according to the analytical geometry. We have to consider a circle. So let it cut the x-axis at A and y-axis at B. Now you take a point on the arc AB whose coordinates are x, y. Join OP. Now this becomes radius OP with respect to the circle according to analytical geometry. Now you draw PM perpendicular to the x-axis, then the distance from y-axis from the point P, it is nothing but it represents the x coordinate of that point, and the distance from the x-axis from the point that is PM or MP, it is nothing but y. Now with respect to trigonometry, now OP becomes the rotating line to measure the angle. We know that to measure the angle in the quadrant, the positive x-axis is considered as the initial line. To measure the angle in the quadrant, we know that the positive x-axis is considered as the initial line. So therefore here OP becomes the rotating line to measure the angle. So let it rotate from the initial line OX, that is positive x-axis, and let it be angle theta. Now using this concept, we know that in the first quadrant both x and y are positive, and hence all the 6 trigonometric ratios, so they become positive in the first quadrant. In first quadrant, all are positive. All the trigonometric ratios are positive when the angle with respect to them lies in the first quadrant, where the angle it lies between 0 degree and 90 degree. We know that 0 degree, 90 degree, 180 degree, 270 degree, 360 degree. So they are called as quadrant angles. They are called as quadrant angles. If we rotate the line OP from the initial position, and if it lies in the second quadrant, then the angle theta, it varies from 90 degree to 180 degree, and hence in the second quadrant, sine and sine theta and its reciprocal cosecant theta, these two ratios will have positive sign, and the remaining ratios, others are with the negative sign. Other ratios are taken with the negative sign. If we rotate the line OP from the initial position, and if it lies in the third quadrant, then the angle, it varies from 180 degree to 270 degree. And hence in the third quadrant we have tan ratio and its reciprocal, that is cot theta. These two ratios we have to take with the positive sign, and the remaining ratios, they are taken with negative sign. If we rotate the line OP from the initial line and it lies in the fourth quadrant, then the angle theta, it varies from 270 degree to 360 degree. In this quadrant we have cos theta and its reciprocal, that is secant theta. These two ratios, they are taken with positive sign, and the remaining ratios are taken with negative sign. So this is called as the quadrant rule. So we should know the quadrant rule also perfectly while solving the inverse trigonometric functions, and this rule, it is applied in the allied angles. So therefore we should be perfect about the quadrant rule. Now after quadrant rule, now we know the values of, that is the standard angles. Here the standard angles are 30 degree, 45 degree and 60 degree. These three angles, they are called as quadrant angles, while 0 degree, 90 degree, 180 degree, 270 degree and 360 degree, they are called quadrant angles. We know the values of all the 6 ratios or the functions for the standard angles, that is 30 degree, 45 degree and 60 degree, and also we know the values of the ratios of the quadrant angles also. So now the next is allied angles. We know that any angle, any given angle of any magnitude, it can be reduced into an acute angle. So with the help of allied angles, we can reduce the given angle of any magnitude to an acute angle. So that is one of the generally the acute angles where we are going to reduce. We get the acute angles as 30 degree, 45 degree and 60 degree. Here allied angle property is any given angle, it can be expressed as n times 90 degree plus or minus theta. N times 90 degree plus or minus theta. So now n, it may be even time or odd number. N, it may be even number or odd number. If the given angle is expressed where theta is an acute angle, where theta is an acute angle. Now if n is even, if n is even number, then the given ratio changes to its co-ratio, remains the same. The given ratio remains the same. If n is even, the given ratio remains the same. But the sign is taken according to the quadrant rule. If n is odd number, then given ratio changes. The given ratio changes to its co-ratio, and the sign is taken according to the quadrant rule. So this is the property of, that is allied angles. That is, any given angle, it can be expressed as n times 90 degree plus or minus theta, where theta is an acute angle. If we express the given angle with the given ratio as n times, where even times 90 degree, then the given ratio remains the same, and the sign is taken according to the quadrant rule, which is very important, this property. If n is odd times 90 degree, that means n is an odd number, then the given ratio, we must change the given ratio to its co-ratio, and the sign is taken according to the quadrant rule. So this is the allied angles, where we use this property while solving the problems in inverse trigonometric functions. So this is about the quadrant rule. So now next is here, that is, we have to know the compound angles. So here, the angles which are in the form of a plus b or x plus y, the sum or difference of two or more angles are called compound angles. The sum or difference of two or more angles are called compound angles. We know the formula for the compound angles, that is x plus y and x minus y. That is sine of, with the ratio, sine of a plus b, it is equal to sin a cos b plus cos a sin b. Cos a sin b. So second one is cos of A plus B, it is equal to cos A sin B, cos A cos B minus sin A sin B. Tan of A plus B, it is equal to tan A plus tan B divided by 1 minus tan A into tan B. So these are the formulae for the ratios with the compound angle, that is A plus B. In this formula sin of A plus B, so here there are two terms, and in the first term, so we have one sin ratio and another one is cos ratio, and the angles are reversed here, interchanged. So sin A here it becomes sin B, cos B, we have to interchange B with A, we get cos A. So if it is plus here also we have to take plus sign. So therefore sin of A plus B, it is equal to sin A cos B plus cos A sin B. Cos of A plus B, in this formula, again there are two terms, where in the first term we must have both cos ratio with the angles A and B, and in the second term we have sin ratio with the angle A and B. Here we have to take the opposite sign. Here if it is plus, here we have to take minus sign. Cos of A plus B, it is equal to cos A cos B minus sin A sin B. So many times we are going to apply, or while simplifying the problems, so we use maximum from RHS to LHS. So cos A cos B minus sin A sin B, it is equal to cos of A plus B. Tan of A plus B, it is equal to tan A plus tan B divided by 1 minus tan A into tan B. Here if it is plus sign, in numerator we have to take plus sign, but in denominator we have to take with negative sign, that is tan A plus tan B divided by 1 minus tan A into tan B. So this is the three formulae for the compound angle A plus B with the three ratios. Now for the compound angle A minus B, so we have, that is sin of A minus B. Again similarly here one sin ratio and cos ratio must be there in both the terms, that is sin A cos B. So if it is minus here, you also have to take minus sign, cos A sin B. You interchange the angles for these two. Next, cos of A minus B, it is equal to cos A cos B. So if here it is minus sign, we have to take plus. So sin A sin B. Next, tan of A minus B, it is equal to tan A minus tan B. So divided by, here if it is minus sign, you have to take minus sign in the numerator, and in the denominator we must have plus sign, 1 plus tan A into tan B. Tan A into tan B. So these are the 6 results or the formulae, so where we are going to use, so while solving the problems, that is for the compound angle A plus B and A minus B. Also A plus B plus C, it is also a compound angle. A minus B plus C, it is also a compound angle. So 2A minus B plus C, it is also a compound angle. But here we are going to consider the two compound angles, one A plus B and another A minus B. So now here, so next, using the formula, that is the results, that is sine of A plus B, cos of A plus B, tan of A plus B. So now if we replace A by pi by 4, that is tan of pi by 4 plus theta, or we can take it as A. So using the compound angle formula, that is tan of A plus B, we get the result as, so tan pi by 4 plus tan theta divided by 1 minus tan pi by 4 into tan theta, that is equal to 1 plus tan theta divided by 1 minus tan theta. So this can also be written as, we know that tan theta equal to sin theta divided by cos theta. So expressing tan theta as sin theta by cos theta in both numerator and denominator and taking LCM, we get cos theta minus sin theta divided by cos theta plus here minus cos theta minus sin theta. So here, while simplifying the problems, so if you have that is the function as the given problem in terms of cos theta plus sin theta divided by cos theta minus sin theta, we can directly express this as tan of pi by 4 plus theta. So it becomes very easy to solve the problem. So next, tan of pi by 4 minus theta. This is equal to, again using the formula, tan of A minus B, that is tan pi by 4, so minus tan theta divided by 1 plus tan pi by 4, so into tan theta, that is equal to 1 minus tan theta divided by 1 plus tan theta. So we can express tan theta as sin theta by cos theta, and we get the result as cos theta minus sin theta divided by cos theta plus sin theta. Again, from this expression, we can express this as tan of pi by 4 minus theta. ಆಯ್ತಾ ಅಂತನಾ? ಹೌದಾ? 1 hour ಅಂದ್ರಲ್ಲ, ಮಾಡ್ಲಾ? ಯಾರು ಕೇಳಿ ಪಪ್ಪ ಕೇಳಿದ್ರ? ಇಲ್ಲ, ಅದು 7:30 ಸ್ಟಾರ್ಟ್ ಆಯ್ತು. ಸರ್ ಸಿದ್ದಪ್ಪ ಸರ್ ಲೇಟ್ ಬಿಟ್ರು, ಅದಕ್ಕೆ. So next year we have to, and also we know the results of next. These are the results, that is with respect to, that is the compound angle formula. The next is here, that is multiple angle formula. The angles like 2A, 3A, 4A, so etc., they are called as multiple angles. 2A divided by 3, or 3 theta divided by 2, or 5 theta divided by 4, etc., they are called as sub-multiple angles. So in particular, that is A divided by 2, or theta divided by 2, or x divided by 2. So in particular, this is called as half angle. It is called as half angle. There are formulas for the multiple angle 2A, multiple angle 3A, 4A, and we have the half angle expressions with the ratios. So here 2A formula, that is sine 2A with the help of the compound angle sine of A plus B, we can, and cos of A plus B and tan of A plus B, we can reduce the results of the multiple angle 2A formula with the ratios. That is, the next one is the multiple angle 2A result. You replace B by A both sides in the above results. We have to replace B by A. Replace B by A both sides. Then we get the results for the multiple angle 2A with the ratios. Now that is, first one is, that is sine of, we get A plus A, it is equal to 2A, then it is equal to sine A cos A, sine A cos A plus cos A sine A. So therefore sine 2A, it is equal to 2 times sine A into cos A, or this is the formula, so expressing both in terms of sine and cos. If you divide the numerator, so and also that is the formula only in terms of tan ratio, it is nothing but 2 times tan A divided by 1 plus tan square A. So this formula, that is only in terms of tan ratio, sine 2A, it can be expressed as 2 times tan A divided by 1 plus tan square A. Is very important while solving the problems. So that is inverse trigonometric functions. That means we have to take the substitution there, that is tan ratio. Now for the second formula, that is cos of A plus B, we have to replace B by A both sides. Then we get cos of A plus A is nothing but 2A. We get cos 2A, it is equal to cos A into cos A, we get cos square A minus sin A into sin A, we get sin square A. So using the identity, here square is there for the ratio, and hence we can use the identity. Using the identity, we can express cos 2A only in terms of sine ratio and also only in terms of cos ratio. We know that cos square A, it can be expressed as 1 minus sine square A. So 1 minus sine square A, we get 1 minus 2 times sine square A. So that is cos 2A only in terms of sine ratio, it can be written as 1 minus 2 sine square A. Similarly, instead of writing sine square A, we can express sine square A in terms of cos square A using identity. That is sine square A, it can be expressed as 1 minus cos square A, and multiplying with minus sign, then we get the result, that is 2 cos square A minus 1. So therefore, we can express cos 2A in terms of, in 3 ways, that is both cos and sine. We express it as cos square A minus sine square A. Only in terms of sine ratio, we can express this as 1 minus 2 sine square A. Only in terms of cos ratio, we can express it as 2 cos square A minus 1. So that is sine 2A, cos 2A. Those results are very important here. Now similarly for the compound angle formulae, that is tan of A plus B, if you replace B by A both sides, then we get, that is A plus A so replacing B by A both sides in the formula, so we get tan of A plus A is 2A, that is tan 2A, it is equal to tan A plus tan A, it is nothing but 2 times tan A. So divided by 1 minus tan A into tan A is nothing but tan square A. So that is tan 2A, we can express it as 2 times tan A divided by 1 minus tan square A. Here cos 2A we can also express, so in terms of only tan ratio. That means here we have to consider this result and we have to take this as divided by 1. 1 we have to use identity, then using that we get 1 minus tan square A divided by 1 plus tan square A. That is cos 2A only in terms of tan ratio. We express it as 1 minus tan square A divided by 1 plus tan square A. That is sin 2A, cos 2A and tan 2A results. So here, while seeing these expressions, so while solving in inverse trigonometric functions, so we should, while taking the substitution, so if we must have the result in this form, so then that means there we have to take x, you have to replace x by tan A, then we can substitute, instead of this result we can write it as sin 2A, and instead of this result we can write it as cos 2A, and the problems it will be simplified. So now these three results, they are called as the multiple angle 2A formulae. Now multiple angle 3A results, that is multiple angle 3A results. With the help of compound angles, identities and multiple angle 2A result, so we can find the results of the multiple angle 3A formula for the trigonometric functions. So here sin 3A, first result, that is sin 3A equal to 3 times sin A minus 4 times sin cube A, 3 sin A minus 4 sin cube A. Next, cos 3A, it is equal to 4 cos cube A minus 3 cos A. That is 4 cos cube A minus 3 cos A. Tan 3A, 3 times tan A minus tan square A divided by 1 minus 3 times tan square A. That is tan 3A, it is nothing but 3 times tan A minus tan square A divided by 1 minus 3 tan square A. So it have both negative sign here. Here also we are having the negative sign. So therefore we must be very careful while writing the formula, because if we interchange the terms, so the formula is wrong. So therefore we must be very careful because of minus sign here. That is sin 3a, it is equal to 3 sin a minus 4 sin cube a. Cos 3a equal to 4 cos cube a minus 3 cos a. That is tan 3a equal to 3 times tan a minus tan square a divided by 1 minus 3 tan square a minus tan cube a. Sorry. So 1 minus 3 tan square a. So now here, that is using for the result of cos 2a, that is we can express it as only in terms of sine ratio and only in terms of cos ratio. Now that is the results of the half angle expressions. That is half angle expressions. With the ratios. So here in the results of, that is sin 2a, cos 2a and tan 2a, you replace 2a by theta and hence a it is equal to theta divided by 2 both sides. In the results of sin 2a, cos 2a and tan 2a formula, we have to replace 2a by theta and hence a by theta divided by 2 in both sides. Then we get the half angle expressions for the ratios, trigonometric ratios. That is the first result here is, that is sin theta, it is equal to 2 times sine, instead of a, we have to use theta by 2, instead of a, again theta by 2, that is 2 times sine theta by 2 into cos theta by 2. Next, only in terms of tan ratio, that is 2 times tan theta by 2. So divided by 1 plus tan square theta by 2. That is sin theta, it is equal to right side, the factors are same. So as in the case of 2a result, so that is, but the angle, we have to take half of that angle. That is 2 times sin theta by 2 into cos theta by 2. Only in terms of tan ratio, we have 2 times tan theta by 2 divided by 1 plus tan square theta by 2. So that is the result of the sine ratio, that is half angle expressions. So similarly, cos theta, instead of 2a, you take it as theta, that is cos square theta by 2 minus sine square theta by 2. Next, only in terms of sine ratio, 1 minus 2 sine square theta by 2. Only in terms of cos ratio, we have 2 cos square theta by 2 minus 1. And only in terms of tan ratio, we have 1 minus, here instead of a, we have to write it as theta by 2 divided by 1 plus tan square theta by 2. So that is the half angle expressions for the ratio, that is cos. And the third one here is for the tan formula, that is instead of 2a, we have to take it as theta, that is 2 times tan. Instead of a, we have to write theta divided by 2, that is 2 times tan theta by 2 divided by 1 minus tan square theta divided by 2. So that is these three results, they are called as half angle expressions for the ratios, sine ratio, cos ratio and tan ratio. So here, so many students, they will be, while writing the formula, they will be get confused. So whether we have to take the minus sign in the denominator or the plus sign in the denominator. To remember this here, to get this result, here we write sine 2a divided by 1. So instead of 1, we use the identity, that is sine square a plus cos square a. So therefore, we get the plus sign here. That is sine 2a, 2 times sine a divided by cos a divided by 1. Instead of 1, we take the identity, that is sine square a plus cos square a, and hence we get the plus sign here. So for cos 2a also, we take cos 2a divided by 1. So for 1, we have to use the identity, that is sine square a plus cos square a. So therefore we get the plus sign in the denominator. But for the tan 2a formula, we are using directly the compound angle result. So where in the denominator we have the minus sign. So therefore here we have to write, that is the minus sign. So that is, we have to remember in that method whether we have to take plus sign for sine 2a and cos 2a. Denominator we have to take plus sign. But for tan 2a, we have to take the minus sign in the denominator. So here, that is cos 2a, we know that it can be expressed only in terms of sine ratio and only in terms of cos ratio. So cos 2a, and also here also cos theta only in terms of sine ratio and only in terms of cos ratio. We have to consider those two. So here we know that cos 2a, it is equal to 1 minus 2 sine square a. We can convert in the different forms. So therefore 1 minus, you shift cos 2a to the right side and 2 sine a to the left side. That is, we get 1 minus cos 2a, it is equal to 2 sine square a, or sine square a, it is equal to 1 minus cos 2a divided by 2. Next, that is cos 2a only in terms of cos ratio, that is 2 cos square a minus 1. 1 right left side tagomandre, so it becomes 1 plus cos 2a, it is equal to 2 cos square a. Therefore cos square a, it is equal to 1 plus cos 2a divided by 2. So using these two, now sine square a divided by cos square a, you divide these two results. Then sine square a divided by cos square a, it is nothing but tan square a. It is equal to 1 minus cos 2a. So divided by 1 plus cos 2a. That is tan square a equal to 1 minus cos 2a divided by 1 plus cos 2a. So these are the results to express sin square A and cos square A in terms of the multiple angle 2A. In terms of multiple angle 2A. Sin square A we can express by using identity as 1 minus cos square A or cos square A equal to 1 minus sin square A. But here using the results, we are expressing the results of sin square A and cos square A. So in terms of the multiple angle, that is 2A. So therefore tan square A, it is equal to 1 minus cos 2A divided by 1 plus cos 2A. So similarly for the half angle expressions also, we have cos theta. First one is, that is cos theta equal to 1 minus 2 sin square theta by 2. Therefore, 1 minus cos theta, it is equal to 2 sin square theta by 2, or sin square theta by 2, it is equal to 1 minus cos theta divided by 2. So that is or sin theta by 2, it is equal to plus or minus. So root of 1 minus cos theta divided by 2. So similarly, cos theta only in terms of cos ratio, that is 2 cos square theta by 2 minus 1. Then we get 1 plus cos theta equal to 2 cos square theta by 2. Therefore, cos square theta by 2, it is equal to 1 plus cos theta divided by 2. So therefore, cos theta by 2, it is equal to plus or minus root of 1 plus cos theta divided by 2. So now, dividing these two results. So we have to divide. So the results 1 and 2, then we get tan theta by 2, it is equal to root of 1 minus cos theta divided by 1 plus cos theta. Next, if we divide equation 2 by equation 1, then we get cot theta by 2, it is equal to root of 1 plus cos theta divided by 1 minus cos theta. So that is, or these two results are used here while solving the problems in the competitive part, competitive exam. So even these two results are also used. So while solving the competitive problems, so then we get the simplified answer easily. So that is, we have studied about, that is up to the compound angles, multiple angles. So that is, today we are going to end here, that is up to the multiple angle formulae.